It happens almost every single day. You're sitting on your couch, you pull out your phone, you find that specific brand of coffee beans you like, and you just click, buy now.
Right.
Or maybe you're walking down the street, you smell something amazing, and you hand over a few bucks to a street vendor for a hot dog. In both of those moments, it feels incredibly simple.
Oh, yeah, it feels completely seamless.
Yeah, it's just a transaction. But the second you make that choice, this invisible, sprawling global machinery suddenly springs into action.
Well, or more accurately, you are experiencing the very tip of a spear that took months, thousands of people, and literally millions of dollars to forge.
Yeah.
Right. Just to make that seemingly simple moment possible.
Oh, exactly.
And it is entirely invisible to the average person by design. I mean, when it works perfectly, you don't notice it at all.
Yeah.
But that hidden architecture is quite literally the nervous system of the modern world.
Yeah.
The moment you click buy now, you are sending a pulse through that entire nervous system.
And decoding that nervous system is basically our mission for today. So welcome to this deep dive. We are going to pull back the curtain on the hidden architecture of the global economy.
I'm really looking forward to this.
Yeah, me too. We're using materials straight from the APICS Certified Supply Chain Professional Learning System, specifically focusing on Section A, Introduction to Supply Chains.
Which is such a foundational text.
It really is. We're going to unpack the basic supply chain models, debate this massive strategic dilemma of whether a company should own every single piece of its process or, outsource it.
The classic vertical versus lateral integration debate.
Right. And then we'll track how supply chains evolve from absolute chaos into digital orchestration. And finally, we're going to look at some surprising real-world laboratories, from hospitals to disaster relief.
That's a huge scope.
It is, which is why helping you, the listener, navigate all of this is our resident expert. You're here to help us understand not just what these systems are, but the mechanics of why they dictate the success or failure of almost every business on Earth.
Well, I am thrilled to dive into this with you. And if I can, ground us before we start unpacking all the granular details.
Please do.
At its core, a supply chain is fundamentally about creating net value. It is this incredible high-wire balancing act of competing interests.
Competing interests like what?
Well, you have global entities, local governments, and entirely different departments within a single company, all trying to synchronize. The ultimate goal is to deliver what you need when you need it, but crucially, without bankrupting themselves or their partners in the process.
Right, which sounds incredibly difficult.
It is. It's really an exercise in managing friction.
Friction is a great word for it. Let's look at the basic anatomy first. I was reading through the ASCM definition, and they define a supply chain as the flow of products, information, and money through a network of partners.
Right, from raw material suppliers to end users.
Yeah, raw materials to end users. And it sounds incredibly linear when you read it out loud like that. But reality isn't linear at all.
Not even close.
If we look at a company like Walmart or Boeing or Airbus, we aren't talking about a single chain. We're talking about a staggeringly complex global web. So the text introduces this concept of echelons to basically make sense of the web.
Yes.
As I understand it, an echelon is just a tier or a level of nodes. Like a factory is an echelon, a consolidation warehouse is an echelon, a retail store is an echelon.
That is the structural framework, exactly. The ASCM Supply Chain Dictionary uses echelons to group operational levels so that managers can actually, visualize the network.
Because you need a map to even begin to manage it.
Right. But there is a golden rule regarding echelons that separates a profitable network from a failing one. Every single echelon must add value.
Because every echelon inherently adds operating expense, right? If I build a new warehouse, I have to pay for the land, the electricity, the workforce, the insurance.
Yep, the overhead is massive.
Plus, I am holding inventory, which ties up capital, and I'm adding to the overall cycle time of getting the product to the customer. So if that warehouse isn't strategically placed
to, say, consolidate shipments to save on freight, or position goods closer to a city to guarantee next-day delivery.
Exactly. If it isn't adding value to the customer experience or the bottom line, it's literally just a giant, expensive parking lot.
Precisely. In supply chain design, an unnecessary echelon is a massive liability. It creates a buffer where inefficiencies can just hide. And connecting all these echelons, these value-adding nodes, are the flows. You mentioned the definition cites products, information, and money. The direction and velocity of these flows determine the entire health of the system.
Okay, so let's break those down. The product flow is definitely the easiest to visualize. It flows downstream.
Downstream toward the end user, yes.
The raw materials become components. The components become a finished product at the factory. The product goes to a distribution center, then a retail store, and finally into your hands, the customer.
Right.
And the cash flow is the exact reverse. It flows upstream. You pay the store pays the distributor pays the manufacturer, and so on.
Those are the primary physical and financial movements, sure.
Yeah.
But the underlying mechanics rely heavily on the hidden flows.
The hidden flows.
Specifically, information. Information flows bidirectionally. I mean, it has to.
Oh, because they have to talk to each other.
Exactly. The manufacturer sends information downstream about product availability, shipping gates, advanced shipping notices. But simultaneously, the customer and the retailer are sending crucial information upstream.
Like point-of-sale data and inventory levels.
Right, and shifting demand preferences. If you don't have that flowing upstream, you're flying blind.
And the text actually makes a very specific point about the flow of strategic requirements. It argues that supply chain strategy does not start with the manufacturer deciding what they want to build.
No, not at all.
The strategy actually originates with the customer and flows upstream.
That is a critical paradigm shift for anyone studying operations. You do not build a supply chain and then look for a customer.
You reverse it.
Exactly. You look at the customer's demands and reverse engineer the supply chain. If your target customer segment demands absolute speed and responsiveness,
say like high fashion apparel or emergency medical supplies.
right. If that's the demand, you must build an agile, fast supply chain. And you often sacrifice some cost efficiency to guarantee that availability.
Because speed is the whole point.
Exactly. But if the customer demands the absolute lowest cost above all else, like with basic paper goods or bulk commodities, you build a slow, highly efficient, lean supply chain.
So the customer dictates the architecture.
A single global corporation might actually have to operate two entirely separate parallel supply chains just to satisfy different customer segments.
We also can't ignore the reverse flows, right? Because if I buy a sweater online and it just doesn't fit, I pack it up and ship it back. That reverse product flow seems like a massive logistical challenge.
So reverse logistics is arguably much more complex than forward logistics.
Really? More complex?
Definitely. It includes returns for refunds, which requires inspecting and repackaging the individual item. It includes warranty repairs, remanufacturing, recycling.
Oh, and I imagine hazardous waste disposal for manufacturing.
Yes, heavily regulated disposal. And just like the forward chain, this reverse chain relies on its own complex web of information flows and cash, often in the form of customer credits, moving back and forth across all those echelons.
Okay, I want to focus on that cash flow for a moment, because the reading emphasizes treating money as a physical flow.
Yes, it does.
And at first, I found that completely counterintuitive. I mean, in the modern era, money is just digits on a screen. We wire it, we use corporate credit cards.
Right, it feels abstract.
Exactly. But the text focuses heavily on this metric called the cash-to-cash cycle time, or the cash conversion cycle. It measures how long it takes for an investment of cash into operations to be returned in the form of cash receipts from sales to customers.
That's the technical definition, yes.
Let me try an analogy here to see if I have the mechanics right.
Please do.
Let's compare it to flipping a house. Say I have $100,000 in cash. I buy a rundown house, I buy drywall, roofing shingles, and I pay contractors.
Okay, I'm with you.
My liquid cash is now physically trapped inside that house. I can't use that money to buy another house or invest in the stock market or pay an unexpected medical bill. The money is literally frozen in the form of a physical asset until I sell the house and the buyer's check clears.
That's exactly right.
So the cash-to-cash cycle time is the exact number of days my money was trapped in that house. In a supply chain, when a manufacturer buys raw aluminum, their cash is trapped in that metal.
Yes.
It stays trapped while it's machined, while it sits in a warehouse, and while it's on a truck.
That is a highly accurate mechanical breakdown. Your capital is frozen in physical inventory. And improving the turnover of those funds, shortening that cycle time, does much more than just improve quarterly accounting metrics.
What else does it do?
It fundamentally reduces systemic risk. When cash is trapped for long periods, companies have to borrow money to meet payroll, which incurs interest, adding to the operating expense. Furthermore, managing this cycle builds or destroys trust between partners.
Ah, right. Because if a massive retailer uses its market leverage to demand like really liberal payment terms from a manufacturer, say, refusing to pay invoices for 90 or 120 days, The retailer is essentially using the manufacturer as a free bank. The
Exactly.
manufacturer's cash-to-cash cycle gets stretched to the breaking point, and they might, in turn, delay paying their smaller raw material suppliers just to survive.
And that cascades down the entire echelon structure.
Yeah.
You end up with localized bankruptcies upstream, which suddenly halts the flow of raw materials.
And then the massive retailer doesn't have products to sell.
Precisely. They end up starving themselves of the very products they need. Consistent, mutually agreed upon rules for integrated cash flows avoid those imbalances. It ensures capital isn't unfairly trapped in one echelon at the expense of another.
That makes total sense. Now, the text mentions cross-docking as a physical innovation designed specifically to accelerate this financial cycle.
Cross-docking is brilliant. It's a perfect intersection of physical logistics and financial strategy. Traditionally, a truck arrives at a distribution center, the pallets are unloaded, a forklift drives them deep into the racks.
And they just sit there.
Right, as trapped capital. They sit there until a store requests them. But in a cross-docking facility, the building is often shaped differently. It's like a long, narrow rectangle with doors on both sides.
Okay.
An inbound truck from a supplier docks on one side. The goods are unloaded, sorted, and moved directly across the floor to an outbound truck bound for a retail store on the opposite side.
So the inventory barely touches the ground. It literally never enters long-term storage.
It bypasses the holding phase entirely. By keeping the inventory in constant motion toward the point of sale, you drastically reduce the number of days the capital is frozen.
That's amazing.
The cash conversion cycle completes faster, freeing up that money to be reinvested in the next batch of raw materials.
Okay, so if a supply chain is essentially this massive, incredibly complex global relay race of materials, information, and cash, the strategic dilemma immediately becomes, well, who should own the runners?
The billion-dollar question.
Right. Should one central authority own the entire track and every athlete on it? Or should you hire independent, specialized athletes to run specific legs of the race?
That dilemma is the defining question of modern organizational strategy. It dictates the entire corporate structure, and it basically presents us with two opposing models: vertical integration and lateral or horizontal integration.
Let's start with vertical integration. This is the model where an organization brings the supply chain echelons inside its own corporate walls.
Yes.
The text uses Henry Ford as the historical extreme of this, and the details are almost hard to fathom today. At his River Rouge plant complex, Ford didn't just want to assemble cars. He wanted absolute, unimpeded synchronization.
You wanted total control over everything.
Right. So he bought the iron ore mines, he bought the coal mines, he bought vast tracts of timberland.
It's wild to think about.
It is. He owned the steel mills, the glass factories, and a fleet of ships and railroads to transport the raw materials. He even owned the rubber plantations in Brazil and the showrooms where the final Model T was sold.
Ford's strategy was built on a desire for absolute control and total visibility. And we really have to understand why he did.
Why go to all that trouble?
Well, in the early 20th century, the external supply base was totally unreliable. Suppliers couldn't meet his massive scale or his exacting quality standards.
So he had to do it himself.
Exactly. By owning every node from the dirt to the dealership, Ford eliminated the friction of negotiating with independent suppliers. He didn't have to worry about a supplier suddenly raising prices to pad their own profit margins.
Or a railroad prioritizing a competitor's freight.
Right. He controlled the schedules, the workforce, and physical locations.
But the downside, as the text points out, is the sheer rigidity of that model. If you own the iron mine and the steel mill, you are legally and financially bound to them.
You're anchored to that technology.
Right. So if a new, cheaper way to make steel is invented by someone else, or if the market suddenly shifts and people want cars made of aluminum or fiberglass, you are stuck holding billions of dollars of obsolete infrastructure.
Yes.
You lose all agility, which is, I guess, why nobody really attempts the River Rouge model anymore.
Not to that extreme, no. The capital expenditure required to maintain world-class capabilities in mining, shipping, steelmaking, and assembly simultaneously is just unsustainable today.
Right.
However, the text provides a fascinating modern evolution of this concept, which is partial vertical integration. And the prime example is McDonald's.
I was really struck by the McDonald's example. They obviously don't own the potato farms or the cattle ranches outright, but upstream, they utilize what the APICS material calls a vested interest model.
The vested interest model is a highly sophisticated financial and operational mechanism. McDonald's forms dedicated, long-term supply contracts with farms and processing facilities.
Okay.
These are often cost-plus agreements, or risk-sharing models.
Meaning McDonald's guarantees they will cover the supplier's cost of production plus a guaranteed profit margin.
Yes.
So the supplier isn't constantly stressed about fluctuating market prices for potatoes or beef.
Exactly. McDonald's removes the market volatility for the supplier. In exchange, McDonald's gains an extraordinary level of control without the burden of outright ownership.
Because they hold all the cards.
Because the supplier's entire financial security is tied to McDonald's, the supplier is highly motivated to adhere to McDonald's incredibly strict specifications for planting, harvesting, and processing.
That makes a lot of sense.
McDonald's essentially dictates the operational reality of the farm as if they owned it, achieving that Ford-level visibility. But their capital isn't permanently trapped in agricultural real estate.
Wow. And downstream, they employ a completely different form of partial integration. McDonald's is famously as much a real estate company as a fast food company.
Oh, absolutely.
They own the physical land and the buildings for almost all of their retail sites. They act as the landlord for their franchisees.
Yes.
By omitting independent third-party commercial landlords, they collect massive, predictable rent revenue, and they maintain ultimate control over the physical locations of their retail echelon.
It's brilliant.
The text actually notes that companies like IKEA and Shell use similar partial integration strategies to manage risk while retaining control over the most critical nodes of their networks.
It is a very targeted application of control, but, for the vast majority of the global economy, the favored approach has shifted away from vertical integration toward lateral or horizontal integration.
Okay, so let's get into lateral integration. This is the practice of identifying your company's absolute core competencies, like the things you do better than anyone else in the world, and outsourcing literally everything else to external specialists.
Right. And the economic drivers for this shift are compelling. It allows a company to achieve economies of scale they could never reach internally, it improves their business focus, and it leverages specialized technological expertise.
To bring this back to the auto industry, the major automakers spent the latter half of the 20th century aggressively dismantling Henry Ford's model.
They tore it apart.
Yeah. Ford divested itself of many internal component manufacturing divisions. Chrysler shed its Mopar Parts division. General Motors famously spun off its entire internal component supplier division into a completely independent organization called Delphi.
The mechanics of that GM and Delphi split illustrate the power of lateral integration perfectly. While Delphi was trapped inside GM as a vertically integrated division, it primarily built parts just for GM cars.
So its scale was limited by GM's market share.
Exactly. But once Delphi was spun off as an independent specialist, it could suddenly bid on contracts to supply components to Ford, Toyota, and Volkswagen.
Oh, wow.
Delphi achieved massive economies of scale, lowering the per-unit cost of producing a steering column or a sensor. GM could then buy those cheaper parts back from Delphi, lowering the cost of assembling a GM vehicle. Both entities became more profitable by separating.
That's incredible. The text also provides a geographic example of this specialization. Many major European clothing brands outsource their entire warehousing and distribution operations to Dutch logistics centers.
Yes. Holland is geographically central to the European market, with access to massive ports like Rotterdam. But more importantly, over decades, specific Dutch logistics firms have developed highly specialized software and automated material handling capabilities.
Built specifically tailored for the apparel industry.
Exactly. They have mastered the incredibly complex reverse logistics of handling clothing returns.
Right, which we mentioned earlier is really difficult.
It is. Inspecting garments, repackaging them, and getting them back into available inventory rapidly. For a clothing brand headquartered in Paris or Milan, it makes infinitely more economic sense to lease that specialized Dutch capability than to spend hundreds of millions of euros trying to build a duplicate network from scratch.
But the text also introduces this hybrid model, the Japanese keiretsu. It seems to sit right on the boundary between vertical and lateral integration.
The keiretsu is a fascinating intermediate form, deeply rooted in Japanese corporate culture. It's a cooperative alliance among a network of independent companies.
Okay.
Legally and economically, they are separate entities with their own balance sheets. However, they engage in cross-shareholding, meaning they own limited amounts of stock in one another. Typically, this network forms around a central financial institution, like a major bank and a trading company.
So they are independent, but their financial fates are completely intertwined. If one company in the Kretsu innovates and becomes highly profitable, the others benefit through their stock holdings. It creates this structural incentive to collaborate rather than ruthlessly squeeze each other for profit margins.
Precisely. It allows them to work with the synchronized trust of a vertically integrated company, sharing long-term strategic planning and R&D costs, while maintaining the specialized focus and flexibility of independent lateral firms.
That brings up the central dilemma of this entire lateral movement, though. If I am an American or European company and I don't have a Kretsu structure, I am outsourcing my manufacturing to a factory in Asia, my shipping to a global freight forwarder, and my IT infrastructure to a cloud provider.
Right, all independent.
They are all independent companies with their own profit motives. If I outsource everything to specialists because they are cheaper, don't I inherently lose the ability to see the big picture? How do I prevent these independent nodes from optimizing their own localized profits at the expense of the overall system's flow?
You have just articulated the central existential challenge of modern supply chain management. When you dismantle the vertical empire, you gain scale and focus, but you shatter visibility and control.
Yeah.
You basically replace a dictatorship with a coalition. And synchronizing a global coalition of independent actors is enormously difficult.
So what is the mechanism to fix it? How do companies actually solve the visibility problem they created by outsourcing?
They cannot solve it through brute force or simple contractual threats. To achieve lateral integration without the system collapsing into disjointed chaos, the organization's approach to supply chain management has to fundamentally mature.
Grow up, basically.
Yes. The APICS text emphasizes that maturity is not merely about purchasing expensive software. It is a cultural, structural, and technological evolution from being a reactive entity simply trying to survive to becoming a proactive network that generates systemic value.
And industry experts generally chart this evolution across 5 distinct stages of supply chain maturity, right?
That's right. 5 stages.
I want to spend some serious time walking through these 5 stages because analyzing the friction points between them really exposes how these systems actually function. Stage 1 is titled Multiple Dysfunction.
Which is putting it mildly.
Yeah, reading the description in the text, it sounds like an absolute nightmare. It is the operational Wild West.
Stage 1 is characterized by a complete lack of synchronized processes. The supply chain is viewed by the executive board purely as a necessary evil, a cost center.
Right. In a Stage 1 company, everything is reactive. If we look at the physical realities, warehouses are likely overflowing with inventory stuffed to the rafters just in case something goes wrong.
Yes.
The workforce is heavily reliant on manual labor with minimal training. There are no advanced shipping notices. Trucks just show up at the loading dock unannounced, causing massive bottlenecks. And the forecasting mechanism is essentially just localized guesswork.
The forecasting in Stage 1 is often the root of the dysfunction. You typically have a marketing department creating overly optimistic sales projections based on promotional hopes rather than historical data.
Oh, wow.
And they just throw those numbers over the wall to manufacturing. Manufacturing builds massive batches of product based on those inflated numbers.
Let me guess.
When the actual customer demand turns out to be much lower, the company is suddenly saddled with millions of dollars in trapped capital unsold inventory, taking up space in those chaotic warehouses.
And the purchasing department in Stage 1 isn't strategic at all. They are entirely transactional. They wake up every day and try to find the absolute cheapest raw materials on the spot market, aggressively squeezing suppliers for pennies.
With zero thought to building long-term reliable relationships.
Exactly.
Because there is no cross-functional communication, the company suffers constantly from the bullwhip effect. A tiny fluctuation in customer demand causes massive panicked over-ordering upstream. The management style is usually defined by firefighting executives giving motivational pep talks or punitive threats to expedite delayed shipments, rather than addressing the structural rot.
The pain of operating in Stage 1 eventually forces the company to attempt some fixes, which leads us to Stage 2, the semi-functional enterprise.
In Stage 2, the company recognizes the bleeding and starts applying tourniquets. They begin to invest in localized improvements.
Like what?
They might purchase some automated materials handling equipment, like conveyors, for that chaotic warehouse. They might install inventory management software on a few computers. They start utilizing basic forecasting algorithms instead of pure guesswork.
But the text highlights a massive catch here. They implement these improvements in strict organizational silos.
That is the defining failure of Stage 2. The departments are trying to optimize their specific functions, but they're doing so in complete isolation, totally oblivious to the collateral damage they are inflicting on the rest of the enterprise.
I really want to explore the mechanics of this silo effect because it seems paradoxical. Let's say I am the director of the traffic and logistics department. My key performance indicator, my KPI, what my bonus is based on, is reducing transportation costs. If I spend weeks analyzing freight routes and I successfully negotiate a contract with a cheaper ocean freight carrier, driving down my department's costs by 15%, how is that a bad thing for the company?
Well, it's as excellent for your department's budget. But let us look at the systemic impact. Ocean freight is significantly slower than air freight.
Right.
Now, suppose that while you were negotiating that cheaper, slower route, the marketing department launched an aggressive, multi-million-dollar campaign promising expedited, rapid delivery to capture market share from my competitor.
Oh, no.
Because you operate in the silo, you never saw their campaign brief. Marketing generated the demand, but because your logistics department unilaterally slowed down the product flow to save money, the company cannot fulfill the promise.
The localized efficiency actively sabotages the macro strategy. The customer experiences a delayed shipment, they leave a terrible review, they never buy from the brand again, and the lifetime value of that customer is destroyed.
Yeah.
All because I saved a few cents per unit on shipping.
Precisely. You optimize the sub-process at the expense of the net value. This plays out constantly in stage 2. Market researchers might spend a fortune uncovering exactly what features customers want in a new product.
But they don't tell anyone.
Right. Because they do not collaborate with the engineering and manufacturing departments, the engineers design a product that is technically brilliant but ignores the market research. Or they design something that the factory floor literally lacks the machinery to produce efficiently.
So the realization hits that optimizing silos is a trap. The company has to tear down the internal walls. They have to get everyone reading from the same sheet music. That cultural and technological shift bridges the gap to stage 3, the integrated enterprise.
Historically, the widespread transition to stage 3 occurred during the corporate technology boom of the late 1980s and 1990s.
Okay.
The hallmark of this stage is a fundamental pivot. The organization stops focusing on individual departmental functions and begins focusing on end-to-end company-wide business processes.
And the technological engine that made that conceptual pivot actually possible was the adoption of ERP, software enterprise resource planning systems.
ERP systems revolutionized corporate management. Before ERP, the sales team had their software, accounting had a different program, and manufacturing used spreadsheets. The databases didn't talk.
Total nightmare.
It was. An ERP system forces the entire enterprise to operate on a single unified database in real time.
The mechanics of that are game-changing. When a sales rep closes a massive order in the field and enters it into the ERP, the manufacturing floor immediately sees the demand spike and can adjust production schedules.
Exactly.
The procurement team instantly sees the bill of materials required and can trigger orders for raw materials. The accounting department sees the projected revenue and can manage cash flow. Information sharing becomes frictionless.
But technology alone does not create an integrated enterprise. The organizational structure must change. This is where we see the implementation of formal S&OP sales and operations planning.
Instead of the traffic department destroying the marketing campaign, the directors of sales, marketing, logistics, and manufacturing are forced into a room on a monthly basis.
They have to.
They have to reconcile their conflicting KPIs. Marketing explains their planned promotions, sales provides their ground-level forecasts, and operations dictates the realistic capacity of the factories and the logistics network. They hammer out a single, consensus-driven operational plan that balances supply and demand.
The text also highlights how product development transforms in stage 3. It shifts to a methodology known as design for manufacturability.
Right, so instead of engineers designing a theoretically perfect product and simply throwing the blueprints over the wall to the manufacturing team,
Who then realize the design requires impossible tolerances or incredibly expensive manual assembly.
instead of that, they form cross-functional teams from day one. An engineer, a factory floor manager, and a procurement specialist collaborate to design a product that the customer wants, but that is also inherently designed to be assembled rapidly, using standardized parts that the procurement team can source cheaply.
Stage 3 represents a mature, internally harmonious organization. Your own house is finally in order. But if we recall our discussion on lateral integration, the modern reality is that most of the supply chain exists outside your corporate walls. You are relying on independent partners.
Which means internal harmony isn't enough anymore. You have to synchronize with external entities. That pushes the organization into stage 4, the extended enterprise.
In stage 4, the corporate boundaries become highly permeable. You take the integrated real-time visibility you achieved internally with your ERP system and you extend it outward.
To who?
You integrate your data networks with the internal networks of your most critical suppliers and your key retail customers. You begin treating independent partners as if they were extensions of your own company.
The APICS material provides a legendary historical case study for this. The collaboration between Procter & Gamble and Walmart, starting with Pampers Diapers.
Yes, a classic.
And the mechanics of how this changed the industry are fascinating. Historically, the relationship between a massive manufacturer like P&G and a retail giant like Walmart was inherently adversarial.
Very.
They sat across the negotiating table trying to squeeze every last penny out of each other's profit margins. P&G was constantly guessing how many diapers to manufacture based on delayed, batch-ordered data from Walmart's purchasing department.
That adversarial guesswork fueled the bullwhip effect we discussed in stage 1. In stage 4, Walmart and P&G realized that the true enemy wasn't each other. The enemy was the trapped capital of excess inventory caused by uncertainty. So they initiated an unprecedented level of data integration.
Walmart basically opened up its electronic data interchange. They started sharing their live point-of-sale data directly with P&G's supply chain planners. Let's trace the data pipeline here.
Go for it.
A customer walks into a Walmart in Ohio and scans a box of diapers at the register. The moment that barcode is scanned, a data packet doesn't just go to Walmart's internal inventory system, it routes directly into P&G's continuous replenishment system.
Instantly.
P&G's manufacturing algorithms register that a box of diapers was sold in Ohio, and they seamlessly trigger the production line to manufacture a replacement box while simultaneously scheduling the logistics to ship it to that specific Walmart distribution center.
The profound shift here is that P&G is no longer manufacturing based on speculative forecasts. They are manufacturing in direct response to actual real-time consumption. It eliminates the need for massive buffer inventories. Both companies achieve radically faster cash-to-cash cycle times, and they share the savings.
The text also highlights Dell Computers as a pioneer of the extended enterprise. Dell achieved an almost unheard-of financial feat, a negative cash conversion cycle.
Dell's model was a masterpiece of lateral orchestration. They built a consumer-facing e-commerce portal where a customer could configure a highly customized computer. When the customer clicked buy, they paid Dell via credit card immediately. Dell had the cash.
But Dell held virtually zero finished goods inventory.
Because the moment the order was placed, Dell's integrated network passed the exact component specifications straight through to their independent suppliers, the monitor manufacturer, the hard drive supplier, the microchip fabricator.
Wow.
Those suppliers rapidly delivered the components to a Dell assembly hub where the computer was built and shipped within days.
So Dell received the customer's cash before they had to pay their suppliers for the components. They achieved total demand and fulfillment integration. In stage 4, your network of partners operates as a single, unified organism competing against other integrated networks.
Which leaves us staring at the final peak of the maturity mountain. Stage 5, the orchestrated supply chain.
Right. If stage 4 already involves real-time integration with external partners, what is beyond the extended enterprise?
Stage 5 is often referred to in modern literature as the supply chain digital transformation, or in European manufacturing circles as Industry 4.0. It is the pinnacle of current operational theory.
Okay.
In stage 4, you connected the data systems. In stage 5, you fully realize the competitive advantage of that connectivity through automation, advanced analytics, and profound organizational agility.
What does that actually look like on a mechanical level?
It requires absolute data integrity. The data flowing through the network must be so accurate and so timely that you can safely remove human intervention from routine decisions. It means utilizing predictive analytics rather than just real-time reporting.
The text mentions predictive maintenance as a prime example of this. Instead of a machine breaking down on the factory floor, causing a massive, unexpected disruption to the flow of product, or even instead of scheduling maintenance every 30 days regardless of need, the machine is embedded with IoT sensors. It monitors its own vibration and temperature, and the AI algorithm predicts that a bearing will fail in exactly 72 hours. The system automatically orders the replacement part, schedules the maintenance during an off shift, and reroutes production to another machine without a human ever having to plan it.
Exactly.
Yeah.
But crucially, the APICS text emphasizes that while Stage 5 is built on advanced technology, achieving it is a deeply human challenge. Orchestration requires sophisticated leadership and an organizational culture that embraces constant disruptive change.
The role of the IT department completely flips here, too. The text explicitly calls this out. In the lower maturity stages, IT professionals are basically plumbers. They're fixing broken servers, patching legacy software, and desperately putting out digital fires.
That's very true.
In stage 5, IT ascends to a strategic leadership role. They are the architects of the network's resilience. They are focused on building robust cybersecurity to protect the integrated data from global threats.
And exploring new technologies.
Yeah, they're exploring how to implement blockchain technology to guarantee the unalterable traceability of raw materials, proving that a diamond is conflict-free, or that a pharmaceutical ingredient was kept at the exact required temperature during transit.
In stage 5, the supply chain is no longer just a mechanism for delivering products. It is the primary engine of competitive differentiation and corporate strategy.
Okay, we have covered immense theoretical ground. We've gone from the chaotic guesswork of the Wild West to machines predicting their own repairs and real-time diaper tracking.
We have.
These 5 stages sound incredibly compelling in a corporate boardroom or an academic textbook. But the theory doesn't matter if we can't observe it in reality. How do these high-level concepts of models, flows, lateral integration, and orchestration apply to the varied, often messy, real world that you and I interact with every day?
That is the essential transition. The APICS curriculum specifically uses diverse, specialized industries as real-world laboratory.
Why do that?
Analyzing these disparate environments helps operations managers strip away industry-specific jargon and recognize the universal mechanics of agility, quality control, and adaptation.
Let's step into those laboratories. I want to start with the most disarmingly simple example provided in the text. We've talked about Boeing and Walmart, but the text explicitly points to a street vendor, a crepe vendor in Paris, or a hot dog cart in Washington, D.C.
It is a brilliant pedagogical example.
At first glance, a hot dog cart does not look like a supply chain. It looks like a person with a propane grill.
True.
If we map the echelons simply, the supplier is the local wholesale food warehouse, the vendor is the manufacturer cooking the meat, and the cart is the retail node. The customer walks up, hands over cash, and receives a hot dog. The entire physical footprint is 10 square feet.
But as the text illustrates, if you look closer, that 10 square feet is a terminal node deeply embedded in a staggering web of invisible dependencies. Consider the utilities required just to maintain food safety. Where does the clean water come from to fill the warming basins? It requires a sprawling, government-managed municipal utility infrastructure. Where does the electricity for the small refrigeration unit come from? Another massive service chain.
The fuel flow is critical, too. The cart relies on pressurized propane. Someone had to extract natural gas, refine it into propane, pressurize it into specialized steel tanks, and distribute those tanks to local hardware stores so the vendor could buy them.
And behind the wholesale food distributor lies a vast agricultural manufacturing network. You have wheat farms and industrial bakeries for the buns. You have meat processing facilities operating under strict federal regulations.
Wow.
You have paper mills in Canada or Scandinavia producing the raw pulp for the napkins and the cardboard boats. And the flows we discussed earlier are all present.
Information flows when the vendor assesses the weather forecast to predict foot traffic and adjust their morning wholesale order. Cash flows horizontally via credit card processing networks. Even reverse logistics are constantly happening.
Absolutely. If the vendor discovers a batch of spoiled meat, it must be returned upstream for credit. The operation generates constant waste-used napkins, food scraps, empty propane tanks, which requires municipal waste management and composting networks to safely remove the byproducts from the urban environment.
It's crazy to think about.
The street vendor proves that there is no such thing as an isolated business. Every commercial act is an intersection of global networks.
It fundamentally changes how you view the world. Once you see the flows, you literally can't unsee them.
No, you really can't.
The text also delves into service industries, which strip away the physical product entirely. They use an electric utility as their primary laboratory for this.
A service chain like an electric utility operates under intense constraints. The inbound flow consists of physical products, massive steam turbines, transformers, miles of copper wire, and raw fuel like coal, natural gas, or uranium.
Right.
But the manufacturing process converts those physical inputs into an entirely intangible output.
Electricity. And the unique terror of this specific supply chain is the almost complete inability to store the finished product at scale. You cannot build a warehouse and stack boxes of electricity in it to buffer against demand spikes.
Exactly. The utility must balance supply and demand perfectly, instantaneously, across a sprawling geographic grid. They distribute this intangible product through highly distinct channels: residential homes, massive commercial factories, and wholesale transfers to other regional grids.
So the information flow is everything.
The telemetry data from millions of smart meters is the only thing preventing catastrophic grid collapse. It is a masterclass in real-time, orchestrated balancing.
Let's pivot from the grid to scenarios where the physical infrastructure is completely compromised, and the stakes are quite literally life and death. The text explores humanitarian and disaster relief supply chains.
This environment strips supply chain management down to its absolute rawest elements. Humanitarian organizations are forced to operate in conditions of total, profound uncertainty.
If a massive earthquake levels a region or a hurricane destroys an island nation, the standard operational assumptions just vanish. The physical echelons are destroyed, warehouses collapse,
Yes.
the transportation networks are compromised, roads are washed out, ports are blocked by debris, the communications grid goes down, blinding the information flow, and the rule of law might temporarily evaporate, creating intense security risks. Simultaneously, the demand for medical supplies, clean water, and shelter spikes exponentially overnight.
Managing that imbalance requires extreme agility. The APICS text highlights a specific organization, Feed My Starving Children, to illustrate how this agility is achieved in practice. When standard networks fail, you cannot rely on automated software or typical corporate contracts.
You can't just boot up an ERP system in a disaster zone.
Exactly. You must rely on human infrastructure.
The text emphasizes that Feed My Starving Children manages this chaos by prioritizing deep personal relationships with local community organizations, churches, and trusted leaders on the ground long before a crisis occurs.
In an environment where infrastructure is broken and the risk of theft, corruption, or misappropriation of aid is incredibly high, human trust becomes the ultimate, indispensable supply chain asset.
Wow, trust as a supply chain asset.
A global relief organization can fly pallets of food into an airport, but without a trusted, pre-established local network to secure the last-mile delivery, that food will simply rot on the tarmac or be seized by bad actors. Trust guarantees the forward flow reaches the vulnerable end user.
Trust as a quantifiable logistical asset. That is really profound. Staying with the theme of life and death, hospitals are another major laboratory examined in the text.
Hospitals represent a fascinating operational paradox. They are service chains under relentless pressure to cut operational costs and improve financial margins. However, patient care and safety are the ultimate non-negotiable order winners.
Right. If an automotive plant cuts corners to save money, a car's dashboard might rattle. If a hospital cuts corners, people die.
So how does a hospital balance the demand for hyper-efficiency with the absolute necessity of zero-defect patient care?
Well, according to the text, they achieve it through intense, digitized visibility and rigorous quality control over their physical inventory. Unlike a retail clothing store where a pair of jeans can sit on a shelf for a year, a significant portion of hospital inventory is highly sensitive and perishable. Medications expire, biological materials degrade.
To manage this, the text highlights the widespread adoption of UDI's unique device identifiers.
UDIs are a brilliant technological mechanism. They are specialized barcodes, or increasingly RFID chips, permanently attached to medical devices, everything from a surgical scalpel to an implantable cardiac stent.
Yes.
When a stent is manufactured, it is assigned a UDI containing its exact batch number, manufacturing date, and expiration date.
So as that stent flows through the echelons, from the manufacturer to the distributor to the hospital's central supply room, and finally into an operating suite, it is scanned at every touch point.
The hospital's ERP system knows exactly where that specific stent is.
Right. If the manufacturer suddenly issues a recall for a defective batch of stents, the hospital doesn't have to manually search through every supply closet. The system instantly identifies if any defective stents are in the building and flags them before a surgeon ever picks one up.
Furthermore, it automates the financial flow. When the UDI is scanned during surgery, it automatically deducts the item from inventory, triggers a reorder from the supplier, and seamlessly adds the exact cost of that specific device to the patient's billing record. It merges patient safety with financial precision.
The text also brings up the COVID-19 pandemic as the ultimate, unprecedented stress test for hospital supply chains.
The pandemic forced a radical, temporary evolution in how hospitals viewed their networks. Historically, major hospitals in a metropolitan area viewed each other as direct competitors, fighting for market share. They kept their inventory levels and supplier contracts strictly confidential.
But when COVID-19 hit, the demand for critical resources, specifically respirators, specialized PPE, and intensive care beds, vastly exceeded the global supply. A hospital operating in a stage 2 silo could not survive.
Exactly. To prevent localized collapses, hospitals were forced into emergency orchestration. They engaged in what the industry calls risk pooling.
Yes, cooling, yes.
They began sharing their deeply confidential inventory data, how many respirators they had available, their real-time burn rate of N95 masks, not just with state emergency management agencies, but directly with their fiercest competitors.
They essentially tore down the corporate walls. If Hospital A had a surge of patients and ran out of respirators, but Hospital B across town had 3 idle machines, they pooled their resources to save lives.
They realized that in an existential crisis, collaborative visibility was vastly more important than protecting their localized competitive advantage. It is a striking example of Stage 4 extended enterprise behavior born out of pure necessity.
It proves that the architecture can adapt when the priorities shift drastically enough.
Let's bring this journey back to where we started in the introduction. Retail, e-commerce, and you, the listener, clicking Buy Now. The APICS material sets up this epic, ongoing structural battle between traditional brick-and-mortar retail and the juggernaut of Amazon.
Amazon's ascent has fundamentally broken the traditional assumptions of retail logistics. They have forced every legacy retailer to completely rewire their operational DNA just to survive.
Let's look at the mechanics of why Amazon broke the system. We talked earlier about cross-docking, the brilliant innovation that traditional retailers like Walmart or Target perfected in the 1990s. Let me try an analogy to contrast the two models based on the reading. The traditional retail distribution network is designed like a city bus system.
Okay, walk me through the bus system.
A traditional retailer builds massive, centralized distribution centers. Suppliers deliver bulk quantities of goods there. The retailer consolidates these goods, fills up an entire 53-foot semi-truck, the bus, with a carefully assorted mix of products, televisions, paper towels, clothing.
Got it.
That fully loaded bus drives to one specific physical destination, the local retail store. The store acts as the final echelon, holding the inventory on shelves until consumers drive to the store, pick the items themselves, and take them home. It is highly efficient for moving massive volumes of goods to a few fixed points.
That is an accurate assessment of the legacy model.
But Amazon didn't build a bus system. They built a system of millions of individual Ubers. E-commerce is not about moving pallets to stores. It is about shipping individual parcels. A single book, a single bottle of shampoo to millions of constantly changing, distinct residential doorsteps.
That analogy perfectly captures the structural divergence. Cross-docking facilities are designed to handle pallets. They are terrible at sorting, picking, and packing millions of individual mixed-item cardboard boxes. Amazon recognized that the final echelon was no longer a retail store. The final echelon was the customer's front porch.
And the text highlights a specific mechanical advantage Amazon uses to dominate this space. They control the inbound flow. Instead of waiting for suppliers to ship products to Amazon, Amazon increasingly uses its own massive transportation network to pick up the items directly from the suppliers' factories.
By controlling the inbound freight, they maintain absolute visibility and dictate the scheduling. But their true mastery is in how they distribute that inventory. They utilize incredibly advanced predictive analytics to distribute their top-selling items unevenly across a massive, sprawling network of highly localized distribution centers. They don't keep all the books in one central hub.
They spread them out.
They analyze local purchasing data, so the specific items you are statistically likely to buy are already physically positioned in a warehouse just a few miles from your house before you even click the button.
This drastically reduces the physical distance the parcel has to travel, which slashes the transit time and lowers the cost of the final mile delivery. So the existential question for traditional retailers is, how on earth do you fight back against a specialized system of millions of Ubers when you are stuck owning a fleet of massive buses?
You cannot beat Amazon by trying to build a better e-commerce warehouse. Traditional retailers have to weaponize the one asset Amazon largely lacks: their massive footprint of physical retail stores.
And we are seeing this mechanical pivot happen right now. Since their centralized distribution centers are not optimized for fast individual parcel shipping, Legacy retailers are fundamentally transforming their physical stores into micro-fulfillment centers.
Exactly. If you go to a major retailer's website and order a shirt or a blender, the algorithm does not necessarily route that order to a massive warehouse 3 states away.
No.
The software locates that exact item sitting on a shelf in a retail store 3 miles from your house. An employee in that store receives a notification on a handheld device, physically walks out to the retail floor, pulls the blender off the shelf, puts it in a box in the back room, and hands it to a local delivery driver.
They are desperately trying to turn their expensive, fixed retail echelons into an agile advantage to match Amazon's localized delivery speed. It is a constant, brutal game of evolutionary adaptation. And it all comes back to mastering those core flows, moving the physical materials, synchronizing the complex information, and accelerating the cash.
From the hot dog vendor, meticulously balancing propane levels in compost bins, to a hospital tearing down competitive walls to share respirator data, to the algorithmic war between Amazon and legacy retail. The mastery of those invisible flows absolutely dictates who survives, who thrives, and who fades into bankruptcy.
This has been an incredibly illuminating journey. We set out to decode the nervous system of the global economy. We started by dissecting the basic anatomy, the echelons, and the vital flows of product, cash, and information. We explored the history of ownership, debating the sheer rigid control of Henry Ford's vertical empire against the flexible, specialized lateral networks that define the modern era. We climbed the steep mountain of supply chain maturity, watching organizations struggle from the chaotic, siloed guesswork of the Wild West into the orchestrated, digitally integrated ecosystems of the extended enterprise.
It's quite a climb.
And finally, we tested these theories in the real world, witnessing how these invisible forces govern disaster relief, hospital care, and the arrival of the cardboard box on your porch.
It reveals a profound level of interconnectivity that most of us take for granted. I hope it provides you with a new operational lens through which to view your everyday interactions.
It absolutely does. Tomorrow morning, when you hand over a few dollars for a cup of coffee, or when you receive a package, I want you to look past the transaction. I want you to remember that you are not just a passive consumer. You are actively participating as the final, most crucial node in this vast architecture.
You are the origin point.
Right. The moment you make a choice, you are firing a pulse of cash and strategic information back upstream, triggering that massive global web of ships, factories, data centers, and human labor into action all over again.
And if I may leave you with a final, slightly provocative thought to mull over as you contemplate that power.
Please do.
We spent time discussing Stage 5 orchestration, where AI systems autonomously predict maintenance and adjust logistics. As these supply chains evolve beyond basic orchestration into highly autonomous predictive networks that ingest mountains of data about our habits, what happens when the supply chain knows what you want before you even consciously realize you want it?
Oh, wow.
As predictive analytics advance to the point where companies begin shipping products to a localized hub, or even directly to your door, based on the statistical certainty that you will order it tomorrow, who is really driving the demand? Are you commanding the supply chain, or is the supply chain beginning to command you?
Oh, that is a wildly compelling, slightly terrifying thought to end on. It fundamentally questions the direction of that information flow. Well, thank you so much for joining us on this deep dive and sharing your incredible insight into these systems. And to you, the listener, keep questioning the architecture around you. Keep looking beneath the surface of the everyday world, and we will catch you on the next one.